Hello! Time to create some images. I have created a really ugly test program here. And I want to use something like this in our game of life code. So here is the function signature I'm aiming for. How big the image should be. We have to give it our world too, so we could get the size from there, but we will need some kind of pixel size, because using pixels that are 1, 1 will just make it look really small. We won't be able to distinguish the cells, so we want some kind of pixel size. Okay, for this I am not sure how to do testing, so we will diverge a bit from that and just do it. So let's create a function called image img. We give it our world and we give it our pixel size, and that should return an image. You have to img perhaps? No? Maybe we need to give it one of these. I suppose. Let's have a look at the. Where is that? Look here. Image. We will use a grayscale image for this first implementation, and we might do color images at a later point. Gray 16. img generates a grayscale image from the world and supplied pixel size from the supplied world and pixel size. Okay. Now let's see here. First we create a rectangle. And that is the size of the image itself. Starts at 0, 0. It doesn't have to, but in our case it's just simpler. And then the world height, the world we have to make this, get this right. Let's see, world. This rect function wants the x coordinate or x length first, which is like that, and then we have to multiply it by the pixel size, and then length of that first row, and then the length of, or the height, pix. That should create a rectangle. And now for our image, I have to look at my cheat sheet. New, okay, of course. New gray 16. And we give it the rectangle. We could just name that R instead, since we just use it for this short amount of time. Short-lived variables, short names. And then we will draw on this image, we will draw the background color. Draw the image, and the what's up next? The image and the bounds method gives us the rectangle we just created, and src image, that I think that is the image that we are going to draw up on our background image. And for that we can use something called uniform, which are, I think that's sort of infinitely large images, and that goes nicely with this background. Uniform, and let's use a white background. I think it was like that, and it should be a pointer, so we have to append that ampersand, the address of operator. Next up is something I don't know, and I haven't bothered to look it up either. Image ZP and draw src. I have no idea what that is. Let's have a look. Image, zero point. Okay. I have no idea why we need that. Maybe it, let's take a look at the signature again. Draw. Golang, draw. I think it's this one we are using. Yeah. I have no idea. It works, so let's keep it at that. Okay, so now we have filled our image with a white background. And now for we should fill it with the contents of the world with black color. I found a nice... The correct way to this is a blog post about the image package. This is the correct way to iterate over an image's pixels. So we see that we iterate over rows first, or vertically, and then horizontally, which is the layout of the slice or the array. Okay. For x equals I have to think about this a bit. Okay, so we start at the minimum y, that is 0, and we go up to the maximum. Actually, here we're looking at the image. That is a bit unnecessary since we have a higher pixel size, so we actually, if for example we have a completely white image with just an a black pixel at 3,3, we do not have to, and pixel size 10, we only have to move in increments of 10. That should be faster. So let's iterate over the world instead. We can keep this here for reference. For y row equals w range w. For, that is how we've done it before, isn't it? Yeah. For x col equals range w, no, x row. Okay. And now we can draw some stuff. Draw at, I'm gonna look at my test program. Yeah. At our image, and then we create a rectangle. Maybe we should do it here. Pixel, imaginary pixel. Image rect, and it should start at we should only, first of all, we should only do this if the cell is alive. So if, or if, yeah, if w x, no, y x is greater than 0, then we can draw some stuff here. This rectangle should be of size it should start at x times pixel size and y times pixel size, and it should go on to x times pixel size plus pixel size, y times pixel size plus pixel size. That is 1 pixel. And let me just reiterate that pixels in this sense is not actual pixels, but just to be able to see the output, we use we scale up the pixels a bit. Okay, so now we have our rectangle. Pixel rectangle. The source image is again image.uniform with color black, and we need the address of that. And then image.zp, what was the last? Draw that. I think that is just the way of telling this function how we should draw, and that we are using a source image. I'm not sure. I may be lying to you, but that's just how it goes. And when we get down here, we should have we should have our image drawn, and then we can probably return it, and then we will use we will create another function for generating the actual GIF file. Let's see here. Here we draw stuff, and then there is the file output. And we should return our image. Cannot use type. Some pointer error here. So apparently our image is a pointer. Maybe we should just return a pointer instead. Now what's that call? Oh, we could just compare to call here. Also, this pixel is reused over and over. We always draw the same size pixel, aren't we? No. We probably have to redeclare that every time. Yeah, never mind. So we have a function that generates a grayscale image. We will stop there, and in the next video we will actually output that image to a file. Bye bye!